Hello students, welcome to the Gate Academy YouTube channel. In this particular session, we are solving the question from the digital circuit subject which is asked in the instrumentation paper, right? So this particular question belongs to the subject digital circuits from the chapter sequence circuits and the topic is counters. The question is like this. A counter is constructed using 3D flip-flops, not 3D flip-flops, using 3D flip-flops. The input-output pairs are D0, Q0, D1, Q1 and D2, Q2, where subscript 0 denotes the LSB. The output sequence is desired to be the gray code sequence. That means regarding 3-bit case, they have given the gray code like this. Okay. Repeating periodically, the expression for D1 is, they have given the 4 choices like this, right? So here, this particular question, they want to design a gray code counter, a 3-bit gray code counter, right? So for that they have used 3D flip-flops, okay, and they are asking the input expression or for D1 flip-flop, okay, what is the D1 expression? Regarding that they have given 4 choices, okay, right? Say for example, if you consider, see you are having the counter, that particular counter will start from here and for each and every clock pulse it will go to the next state in this sequence, and after reaching to this particular state it will come back to original state like that, right? So for the timing you can assume this is like present state, and here we'll write the next state, okay, and here you can assume Q2, Q1, Q0. If this is the present state, next state will be like this, Q2 plus, or you can assume if this is Q2 of t, this will be Q2 of t plus 1, like that also you can assume, no issue. Q1 plus, Q0 plus. Okay, suppose if this is the present state, next state will be this one, so you can write here 0, 0, 1. Similarly, if present state is this one, next state will be this one. So in this way, you can write the next states in this order. Okay. Next you will get 0, 1, 0. Next 1, 1, 0. Then 1, 1, 1. 1, 0, 1. 1, 0, 0. Now, once if you reach to this particular state, next state will be what? Original state. Okay. So that means 0, 0. 0, 0. I hope all of you are very much familiar regarding the characteristic equation of D flip-flop. What is the characteristic equation? It is very simple, right? Say for example, for second flip-flop I am considering. You are having 3 flip-flops. Okay, regarding the middle one I am considering. Q1 of t plus 1 is nothing but D. Q1 of t plus 1 is nothing but D1. Right? Whatever the input you are having, that will come at the output for next clock cycle, right? Okay. So this Q1 of t plus 1 currently I have considered as Q1 of plus, Q1 plus, that's all. Okay. So that means what? This is nothing but your input only. Q1 of t plus 1 is nothing but D1. Okay. Now they are asking regarding D1 expression, right? So just observe, here you are having the present state. So with respect to this, in terms of these variables, you have to represent the expression for D1. That's all. Okay. So here you are having 3 inputs or 3 variables. So you can get the expression for D1 by using 3 variable K-map. So we can get the expression for D1 by using 3 variable K-map. So here the inputs are Q2, Q1, Q0. Okay. So in general you are very much familiar. Whenever you are having the truth table, right? So for whichever combination of inputs, you are getting the output as 1, right? So accordingly you can place the ones in the respective cells. Okay. But here the one interesting thing is, in general you will write the binary input in a sequence, right? Starting from all the bits 0 to all the bits 1. But here you are having the gray code. So you have to be very careful while writing the ones here, right? Okay. So just observe only this column. Okay, wherever you are getting 1, just observe the respective input combination and accordingly you can place the ones in the respective cells. Okay. So here 0, 0, 1, output is 1. 0, 0, 1, output is 1, right? So that means here output is 1. Next 0, 1, 1, 0, 1, 1, output is 1. Okay, next 0 1 0, output is 1. Next 1 1 0, output is 1. 1 1 0, output is 1. So you have to be careful. If you forget, if you assume this is like your binary, then you may get wrong expression, right? So you have to be very careful. For whichever input combinations you are getting output as 1, those input combinations you have to observe carefully here, and you can place the output as 1. Okay. Now you can do the groupings. You can do grouping of these two ones, and you can do the grouping of these two ones. So regarding this row wise grouping, row wise, if you observe Q2 value is 0, that means Q2 bar. Column wise, Q0 value is 1, right? So you'll get Q0. Next, for this particular grouping, column wise, you're having Q1 value is 1, Q0 value is 0, that means you'll get Q0 bar. Now, here if you observe, these two are compulsory grouping, right? See, if you want, you can do grouping of these two ones, but that is not required in the final answer, right? Because these two are essential prime implicants, so the answer will be what? Just observe Q2 bar Q0 plus Q1 Q0 bar. Yes. So that means option C is the correct one. Okay. So only one twist is here they have mentioned it is a gray counter, 3-bit gray counter, right? So while placing the ones, if you written the ones in the appropriate places, in the respective places, then you'll get the correct answer. Otherwise, you may get wrong answer. I hope this solution is beneficial for you. So please like and share this video with all of your friends. Thank you all.